Welcome to our practical journey into Kotlin Coroutines. In today's fast-paced Android development world, managing multiple threads, network calls, and UI updates can quickly become overwhelming. That's where Kotlin Coroutines step in, offering a modern, efficient way to handle asynchronous programming. In this video, we'll start from the basics and gradually build up to advanced usage, focusing on both Android and Kotlin Multiplatform, KMP projects. Whether you're a beginner or looking to sharpen your skills, this guide will help you write readable, maintainable async code that integrates seamlessly with ViewModels, flows, and shared logic. Let's dive in and see how coroutines can transform your development workflow. As mobile apps grow more complex, they need to perform multiple tasks at once, fetching data from the internet, saving user preferences, and updating the interface, all without making the app feel slow or unresponsive. Traditional approaches to asynchronous programming can lead to tangled, hard-to-read code. Kotlin Coroutines address this by allowing you to write code that looks sequential but runs asynchronously under the hood. This means you can keep your code clean and logical, while still taking full advantage of modern hardware and software capabilities. Understanding why async matters is the first step toward mastering coroutines. At its core, a coroutine is Kotlin's way of writing asynchronous code in a sequential style. Imagine being able to write code from top to bottom, just like you would for a simple script, but with the power to pause and resume execution as needed. Coroutines can suspend their work without blocking the underlying thread, waiting for data or resources to become available, and then pick up right where they left off. This makes them incredibly efficient and lightweight, enabling thousands of coroutines to run on just a handful of threads. Let's break down what makes coroutines so special. One of the standout features of Kotlin coroutines is their lightweight nature. Unlike traditional threads, which are expensive to create and manage, coroutines are designed to be minimal in resource usage. You can easily have thousands of coroutines running simultaneously without overwhelming your system. This efficiency is made possible by the way coroutines handle suspension and resumption, only using threads when absolutely necessary. This means your app can scale to handle many tasks at once, all while keeping performance smooth and battery usage low. Suspending functions are the backbone of coroutines. These special functions can pause their execution at any point, waiting for a result or resource, and then resume when it's ready. This allows you to write code that looks and feels synchronous, but actually handles asynchronous operations under the hood. For example, you can fetch data from a server, wait for a response, and then update the UI, all in a single, readable function. This makes your code easier to understand, maintain, and debug. It's important to understand how coroutines differ from traditional threads. While threads are managed by the operating system and can be heavy on resources, coroutines are managed by the Kotlin runtime and are much lighter. This means you can launch many more coroutines than threads, making them ideal for modern app development. Coroutines also provide structured concurrency, helping you manage their lifecycle and avoid common pitfalls like memory leaks or orphaned tasks. One of the biggest advantages of coroutines is the ability to write asynchronous code in a sequential style. This means your functions and logic flow naturally, just like synchronous code, but with the added benefit of non-blocking execution. This makes your codebase easier to read and reason about, reducing bugs and improving maintainability. Developers can focus on business logic without getting bogged down by callback hell or complex thread management. Kotlin coroutines are a perfect fit for Android development. They integrate seamlessly with ViewModels, LiveData, and other architecture components, making it easy to manage background tasks and UI updates. With coroutines, you can perform network requests, database operations, and other long-running tasks without freezing the UI. This leads to smoother, more responsive apps that delight users and stand out in the crowded app marketplace. Kotlin Multiplatform, KMP, allows you to share code between Android, iOS, and other platforms. Coroutines play a key role here, enabling you to write shared asynchronous logic that works across all your targets. This means you can implement business logic once and reuse it everywhere, reducing duplication and speeding up development. KMP and coroutines together are a powerful combination for building modern, cross-platform apps. ViewModels are a core part of Android's architecture, responsible for managing UI-related data. Coroutines integrate perfectly with ViewModels, allowing you to launch background tasks and update the UI safely. By using structured concurrency, you can ensure that all coroutines are properly canceled when the ViewModel is cleared, preventing memory leaks and unexpected behavior. This makes your app more robust and easier to maintain. Kotlin's Flow API brings reactive programming to coroutines, allowing you to handle streams of data in a declarative way. Flows are perfect for observing changes in your database, responding to user input, or processing network responses. They work seamlessly with coroutines, making it easy to collect, transform, and combine data streams in your app. This leads to more responsive, interactive user experiences. Structured concurrency is a key concept in coroutines, ensuring that all asynchronous work is tied to a specific scope. This makes it easy to manage the lifecycle of your coroutines, automatically canceling them when they're no longer needed. Structured concurrency helps prevent resource leaks and keeps your app stable, even as it grows in complexity. It's a best practice for any coroutine-based project. Start a coroutine. You use builders like launch or async. These functions create a new coroutine and run your code inside it. The launch builder is perfect for tasks that don't return a result, while async is used when you need a value back. By choosing the right builder, you can control how your coroutines execute and interact with the rest of your app. Coroutine scopes define the boundaries for your asynchronous work. By attaching coroutines to a scope, you ensure they're automatically canceled when the scope ends. Common scopes include ViewModel scope for ViewModels and lifecycle scope for activities and fragments. Using scopes helps you manage resources efficiently and avoid leaks. Dispatchers determine which thread or thread pool your coroutine runs on. The main dispatcher is used for UI updates, I/O for network and disk operations, and default for CPU-intensive work. By choosing the right dispatcher, you can optimize performance and keep your app responsive. Switching dispatchers is as easy as calling with context, making it simple to move work between threads. Handling errors is crucial in any asynchronous code. Coroutines provide structured ways to catch and handle exceptions, ensuring your app remains stable even when things go wrong. You can use try-catch blocks, coroutine exception handler, and supervisor jobs to manage errors gracefully. This keeps your user experience smooth and prevents crashes. Retrofit is a popular library for network calls in Android. With coroutines, you can make retrofit requests in a clean, sequential style, without callbacks or complex threading. This makes your networking code easier to read and maintain, while still being highly efficient. Coroutines and retrofit are a powerful combination for modern Android apps. Room is Android's recommended database solution, and it works beautifully with coroutines. By marking your DAO functions as suspend, you can perform database operations without blocking the main thread. This keeps your UI smooth and responsive, even when working with large datasets. Coroutines make it easy to integrate Room into your app's architecture. Updating the UI from background threads can be tricky, but coroutines make it straightforward. By using the main dispatcher, you can safely update views and interact with the user interface from your coroutines. This ensures your app remains responsive and avoids common pitfalls like crashes or inconsistent state. Testing asynchronous code can be challenging, but Kotlin Coroutines provide tools to make it easier. You can use test coroutine scope and run blocking tests to simulate coroutine execution and verify your logic. This helps you catch bugs early and ensures your code works as expected in all scenarios. Get the most out of coroutines. It's important to follow best practices. Always use structured concurrency, choose the right dispatcher for each task, and handle errors gracefully. Keep your coroutine scopes tied to the lifecycle of your components, and avoid launching global coroutines unless absolutely necessary. These habits will help you write robust, maintainable async code. Even with coroutines, it's possible to run into issues if you're not careful. Common pitfalls include forgetting to cancel coroutines, using the wrong dispatcher, or leaking resources. By understanding these risks and following best practices, you can avoid most problems and keep your app running smoothly. Debugging asynchronous code can be tricky, but Kotlin Coroutines provide tools to help. You can use logging, breakpoints, and structured concurrency to trace coroutine execution and find issues. Tools like Android Studio's debugger and the Kotlin Coroutines debug library make it easier to see what's happening under the hood. Coroutines are efficient by default, but you can optimize performance even further. Profile your app to find bottlenecks, use the right dispatcher for each task, and avoid unnecessary context switches. By tuning your coroutine usage, you can deliver fast, responsive apps that delight users. Ever wondered how coroutines actually work? Under the hood, they use continuations to save and restore execution state. This allows them to pause and resume without blocking threads. Understanding the internals can help you write more efficient code and debug tricky issues when they arise. Many projects have existing code that uses callbacks or threads. Coroutines can integrate with legacy code using suspend coroutine and other bridging techniques. This allows you to gradually migrate your codebase to coroutines without a complete rewrite, making adoption smoother and less risky. Dependency injection frameworks like Dagger and Hilt work well with coroutines. By injecting coroutine scopes and dispatchers, you can keep your code modular and testable. This leads to cleaner architecture and easier maintenance as your app grows. Kotlin Multiplatform lets you share business logic across Android, iOS, and more. Coroutines make it possible to write shared async code that works everywhere. This reduces duplication, speeds up development, and ensures consistent behavior across platforms. When you're ready to ship your app, coroutines help ensure it's robust and scalable. By following best practices, testing thoroughly, and monitoring performance, you can confidently use coroutines in production. Many top apps rely on coroutines for their async needs. The Kotlin community offers a wealth of resources for learning and mastering coroutines. From official documentation to open-source projects and forums, you'll find plenty of support. Engaging with the community can help you solve problems, discover best practices, and stay up to date with the latest developments. If you're new to coroutines, start with the basics and gradually build up your knowledge. Practice writing simple suspend functions, experiment with different dispatchers, and explore structured concurrency. As you gain confidence, tackle more advanced topics like flows, testing, and integration with other libraries. Seeing coroutines in action can help solidify your understanding. Look for sample projects, tutorials, and open-source apps that use coroutines effectively. Analyze how they structure their code, handle errors, and optimize performance. Real-world examples provide valuable insights and inspiration for your own projects. Managing UI state is a common challenge in app development. Coroutines make it easier by allowing you to update state in response to async events, such as network responses or user actions. By combining coroutines with state management libraries, you can build responsive, predictable interfaces. As you become more comfortable with coroutines, explore advanced patterns like channels, actors, and select expressions. These tools allow you to build complex async workflows, coordinate multiple tasks, and handle concurrency with ease. Mastering these patterns will take your coroutine skills to the next level. If you're working on an existing project, migrating to coroutines can seem daunting. Start small by converting simple async tasks, then gradually refactor more complex logic. Use bridging techniques to integrate with legacy code, and test thoroughly to ensure everything works as expected. Clean architecture emphasizes separation of concerns and testability. Coroutines fit perfectly into this model, allowing you to keep async logic in your domain and data layers while keeping the UI layer simple. This leads to more maintainable, scalable apps. Many open-source projects use coroutines to handle async tasks. Studying these projects can give you practical insights into coroutine usage, best practices, and common patterns. Contributing to open source is also a great way to deepen your understanding and give back to the community. Kotlin coroutines are constantly evolving, with new features and improvements released regularly. Stay up to date by following official announcements, reading blogs, and participating in community discussions. Keeping your knowledge current ensures you can take advantage of the latest tools and techniques. Modern Android development relies heavily on coroutines for async programming. With official support from Google and deep integration with Jetpack libraries, coroutines are the go-to solution for background work, data streams, and UI updates. Embracing coroutines is essential for building high-quality Android apps. To truly master coroutines, practice is key. Tackle coding challenges, participate in hackathons, and experiment with new patterns. The more you use coroutines, the more comfortable you'll become, and the better your apps will be. Challenging yourself with coroutine puzzles is a great way to deepen your understanding. Try solving problems that require you to coordinate multiple coroutines, handle errors, or optimize performance. These exercises will sharpen your intuition and prepare you for real-world scenarios. Mastering coroutines can open up new career opportunities. As more companies adopt Kotlin and modern Android practices, expertise in coroutines is in high demand. By building your skills, you'll be well positioned to advance your career and take on exciting new challenges. Let's recap what we've learned. Kotlin coroutines provide a powerful, efficient way to handle asynchronous programming in Android and KMP projects. By writing readable, maintainable code, you can build robust, responsive apps that scale from small prototypes to production. Remember to follow best practices, keep learning, and engage with the community to stay ahead. Ready to take your coroutine skills further? Explore advanced topics, contribute to open-source projects, and share your knowledge with others. The journey doesn't end here. There's always more to learn and new challenges to tackle. Keep experimenting and pushing the boundaries of what you can build with Kotlin coroutines. Thank you for joining this practical journey into Kotlin Coroutines. We hope you've gained valuable insights and feel inspired to apply what you've learned in your own projects. Stay curious, keep coding, and don't hesitate to revisit this guide whenever you need a refresher. Happy coding!